In this video, we're going to review the idea of special right triangles. You may recall from geometry the idea of a 30, 60, 90 special right triangle, or a 45, 45, 90 special right triangle. These numbers all refer to the angles of the triangle. And again, they're both right triangles, so of course they both have a 90-degree angle. Now, in all of these examples we look at, we're going to assume our hypotenuse is 1. This is going to be extremely important when we talk about the unit circle. So for these purposes, all of our hypotenuses are going to be 1. The one other thing you need to know before we continue is the Pythagorean theorem, right here at the bottom. A squared plus b squared equals c squared. The important thing is that it's just side squared plus side squared equals hypotenuse squared. No matter what we call these sides, side squared equals hypotenuse squared. Our first example of a special right triangle is the 45, 45, 90 right triangle, drawn here in the center. 45, 45, and then the right angle down here, 90 degrees. And again, notice our hypotenuse is a 1. Now we're going to use the Pythagorean theorem to try to find out what these sides are. The important thing you have to remember from geometry is that in an isosceles triangle, two angles are equal, which makes the two opposite sides equal. So I know that this side and this side are exactly the same length because they have the same opposite angle. So I've labeled them both as A. I could have labeled them as B, but whatever it is, I can pick the same letter to represent both of them since they are the exact same length. So over here I've written out on the right my Pythagorean theorem, a squared plus b squared equals c squared. My hypotenuse is 1, so it's 1 squared. So if I have a squared plus a squared, well, that's just going to be 2a squareds. And 1 squared is, of course, just 1. So I've rewritten it as 1. Alright, so I'm going to walk us through solving the rest of this. Of course, I want to now divide by 2 here to get rid of the 2 on that side. Divide by 2. So now I'm left with a squared equals 1/2. Well, at this point, I'm going to take the square root of both sides to get rid of my square root of both sides. So I have a equaling the square root of 1/2. This is when things are going to get a little bit more complicated. I'm going to simplify this to 1 over the square root of 2. If I have the radical of a fraction, I can change that to, the square root of a fraction, I can change that to the square root of the numerator divided by the square root of the denominator. Square root of 1 is just 1, square root of 2 I'm going to leave as 2. So I have a equals 1 over the square root of 2 at this point. If you now direct your attention over to the left of the screen, you'll see I've rewritten 1 over the square root of 2. The next few steps are going to take us through a process called rationalizing the denominator. Rationalizing. This process goes back to times before calculators. In the world before calculators, mathematicians didn't like dividing by a square root. It's an irrational number and makes division extremely difficult. So what they decided to do was multiply by a fraction that's equivalent to 1 that would make the denominator a whole number. So essentially what you do is you multiply it by the square root of 2 over square root of 2, since we had a square root of 2 in the denominator. So you multiply it by the square root of 2 over the square root of 2, since that was in the denominator. And then if you follow the light down here, I just multiplied across and got 1 times the square root of 2 is the square root of 2. Square root of 2 times the square root of 2 gives us the square root of 4, which, following the light down here, I've simplified the square root of 4 to 2. And this is actually the final answer that we're looking for. A equals the square root of 2 over 2. This is going to be an extremely important number in trigonometry, so start getting used to it. And we know the other side is also the square root of 2 over 2. Our second type of special right triangle is going to be a 30, 60, 90 right triangle. So in the center of this screen, you can see I've drawn not a 30, 60, 90 right triangle, but actually an equilateral triangle. So a triangle with 3 equal sides. Something you may remember from geometry is that if you have a triangle with 3 equal sides, the 3 angles are also equal, and they will each be 60 degrees. So you can see I've written 60 down here, 60 down here. This one I've left blank, but you will see why in a moment. In order to create a right triangle, I've then drawn a dashed line down the center, so breaking this top 60-degree angle into 2 separate 30-degree angles, and dividing the bottom into 2 pieces, each of which is half of what the whole base used to be. So just to make that a little bit more clear, I'm going to put a nice box over this half so that we're not even looking at it anymore. Can't even see it. So now what I'm looking at here is a right triangle with angles 60 degrees, 30 degrees, and 90 degrees. How convenient. As I stated before, I've labeled my hypotenuse as 1. And then, since I created this bottom piece by dividing my original triangle into those 2 pieces, I know that this side must be half of what we had before. So just this piece right here is going to be 1/2. If I had said this whole side was 1, since it was equal to this side, this part right here must be 1/2. So let's put our covering back on here. So the only side I'm left wondering about is this straight, this straight side right down the center. And I've labeled that as A. Let me move my box so you can see that. That's A. So, without much else to do, I'm going to set up a Pythagorean theorem. I know A squared plus 1/2 squared, A squared plus 1/2 squared, is going to equal my hypotenuse squared, which is 1, so 1 squared. Again, leg squared plus leg squared equals hypotenuse squared. Well, I know 1/2 squared, if I was to multiply 1/2 by 1/2, it's going to give me 1/4. And then 1 squared is just 1. So right here I've just rewritten the equation by simplifying a few things. Let's go through the last steps together. So to solve for A, I'm going to now subtract 1/4 from both sides of the equation. So that will cancel out. I'm now left with A squared equals, well, 1 minus 1/4, that's going to be 3/4. Whoops. Get rid of that. There we go. 3/4, not 3/3. Well, now I have A squared equals 3/4, but I wanted to know what A was. So square root both sides, get rid of my square root this side. I now have A equals the square root of 3/4. And now I'm going to use that trick that I used before that says the square root of a fraction is the same thing as the square root of the numerator divided by the square root of the denominator. So I know A equals the square root of 3, so the square root of the numerator, divided by, and now I need the square root of 4, but I know that's just 2. So I can say A equals the square root of 2. And that's going to be my final answer here. Square root of 3 over 2. Again, another extremely important number in trigonometry. So get used to this one too. Square root of 3 over 2. Okay, so let's summarize what we just reviewed. We looked at two types of special right triangles, and we determined the side lengths of those special right triangles based on the fact that the hypotenuse was 1. So given a hypotenuse of 1, we were able to determine the other two side lengths using just the Pythagorean theorem and our knowledge of square roots. You may be asking yourself, why are there 3 triangles here? We only looked at 2. Well, you want to notice that this first one is a 30, 60, 90. The second one is a 45, 45, 90. And the last one is actually just another 30, 60, 90 in disguise. These two are the same. They've just been rotated. So the square root of 3 over 2 side is across from the 60 on the left, and on the right triangle, the square root of 3 over 2 side is still across from the 60. So nothing has changed except the triangle has been rotated. 1/2 is across from the 30. Same thing over here. 1/2 is across from the 30. So this is a nice summary slide that you may want to refer to in the future. On this last slide, please find your homework problems. All you'll need to do in 1, 2, and 3 is rationalize the denominator. In other words, rewrite with no square root in the denominator. So you're going to want to multiply by an equivalent, a fraction equivalent to 1. That's essentially the denominator over the denominator, just like we did in the 45, 45, 90 right triangle.